Today I'm going to talk about how I tried to fix service Locators. Who knows? Let me ask some questions before I start. Who tried Dart? Dart. Dart is a programming language. It's basically mostly used for creating mobile apps with Flutter. It looks like Java, feels like Java, but it also has some nice stuff, and is inspired by some more languages too. And who knows what is a service locator? Okay, let me do a quick introduction to the concept maybe before I start. Service locators are it's actually a design pattern that lets you register your dependencies somewhere and then retrieve them via abstracting everything so that you don't know anything about the implementation itself, and it makes life easier because your classes that use some other classes, they only need to know the interface of whatever they are going to use. For example, let's say I'm a kid, I'm opening the refrigerator and I want to take something, but I can do it wrong because I don't know, I'm a kid. And instead of trying to get some juice or water or whatever, I can tell the refrigerator or my parents, I guess, please give me something to drink, and they're going to figure out what you need. So that's kind of the concept of service locators. And basically, usually their implementation is just a hash map with the type as the key and something internal as a value. And they just keep references to objects and stuff. And most implementations let you create different kind of objects or stuff that you can get, like singletons or factories or something else. And everyone knows what a singleton is, right? Singleton is basically a class that only one instance of it can exist in the whole app, and it's actually an anti-pattern because it's not good to have classes singletons hard-coded in them, but sometimes you really do need to have some global instance or something. That's when you can create something global and then use it. One way to do that would be by using global variables, which is bad because, I don't know, it's just bad. And another way is using this thing called service locator. So today's talk I'll be using Dart because that's what tour is in, and I'll try to demonstrate you the way you would do it before tour and after, because as I already said, service locators are usually hash maps, and the way you retrieve something is just you provide a type and you tell me, give me something of this type. Let's try to demonstrate that with okay. Dependencies, get it. Let's say we have a function called something like configure dependencies, which what it does is basically it configures dependencies, and instance. Sorry. Okay. So Gettys is the classical implementation of service locator. You just register your stuff, You can register, I don't know, singletons or lazy singletons or factories. And then the way you retrieve them is just you tell the locator, just give me an instance, whatever you have of this type. And let's say you could like register, you could have a class A, which is int p. Yeah, and you kind of this is how you registered a singleton of class A. If the way you retrieve it later is you like ask get it to please give me something of type A. This is your class that you retrieved. What's the problem here? The problem is, let's just print B and maybe run this so that we can see what happens. What happens now? Check operator used in because we look, this is a very good demonstration of why the default way of doing things is bad, because compile time, your program doesn't know whether or not you have a dependency like created, registered, etc. And you get runtime errors pretty usually. And it's bad because we know that runtime errors are generally, they are like a little bit harder to catch if you have some Crashlytics system like Firebase Crashlytics, or you have maybe Sentry integrated. You will see that, but you won't be safe anyways. And service locators usually do some shady stuff because it's all runtime, you don't define anything. There are ways to kind of solve that issue, but they aren't completely solving it. So then one day I thought that what if I could create a compile time safe service locator? The idea sounded crazy and interesting to me because like their whole nature is not compile time safe. And then I did it, and it wasn't that hard, and it's very simple actually. And that's how we have like Tur. Tur is like give in Armenian because you like want something from the locator and it gives it to you. And yeah, it makes just service locators compile time safe and easy to manage and use and stuff. And what's the idea of Tur? Like you still have a single instance. You can actually have different instances if you want for whatever reason. And the way you register dependencies is you create variables for them. And they are usually global variables, but they don't hold the implementation itself. They just hold an internal object that manages all the stuff. And this gives you an additional layer of abstraction, and you can maybe reset them later if you want easily, or you can even create different instances and reset only whatever you need. Let's maybe take a look at how this works with Tur instead of something like get it. For that, I need to okie dokie, we have it. Let's just like get it, create an instance of Tur, and try to register it. And Tur heavily uses lazy initialization features of Dart. Basically, you can have stuff not only create it whenever you try to access it and use it. And it's very helpful because it lets you to save some memory that you don't really need before using the thing. Okay, so you create lazy variables by using the late keyword for some context. And let's try to register singleton here, what we do is we say, hey tour, please, I want a singleton. They are actually, you can only create lazy singletons because actual singletons don't really make sense. And yeah, we say that it's of type A, and here we want to have the implementation, basically. And the way you use this is you just call it. And here you have a singleton. You can, this is actually some syntactical sugar. You could also do .get if you need that, but let's check our cooler A. And the coolest thing about all of this is you never get errors when trying to access something, because it's all statically defined, it's all compile time self, and it's safe. What advantages does this have besides being compile time safe? You can also register factories. Factories are methods that create objects. Why do you need them? Because you don't want to create your implementations in your app, and you want, again, some kind of abstraction to abstract it away. For example, this could also be a factory, and this time it wouldn't really be every time. Okay, let's okay. So if you try to instantiate two instances of a singleton, this would print true because this is a singleton. And factories create like two separate objects. And you shouldn't really use singletons that often to start with. And the thing is, factories often have parameters because you want to pass some data to your factories. And how you do that in something like getIt in classical service Locators is you have nullable get, sorry. Wait. You basically have like a nullable parameters. Nullable means you can pass them or not. And you can break something while doing that, because I'm trying to find the definition, but it's the documentation is like too, I don't know, get it. Instance. Get. Here we go. Here it is. So the way you do that in getIt or some classical other service Locators is for your function that provides you with some parameters, you have like dynamic parameters. They don't have types. You can pass whatever you want, and you won't get an error. You cannot pass them, and like you won't get an error compile time, but it will break because it's not going to work. What Tour lets you do is, since recently I implemented it like yesterday or something, you can have factories with parameters. Let's try that, like factory with param. You can do Tour register factory with one parameter or two parameters, because it's like, yeah, you don't need more than that. You provide the type of the factory, and you provide the type of the parameter. Let's say that they both are strings, and we create a lambda function here just because we want that, and param1, and we can return that param1 is compile time safe. Okie dokie. Let's try using that. What if we do like Once we try to get this, it will give us an error saying that one positional argument was expected, because Tour already knows that there needs to be a parameter and the factory won't be created without it. What if we try to pass an integer here? It will tell us that you cannot assign int to string. But if we pass the actual parameter, yeah, here it is, our parameter. Maybe I need to. Here you go. It says that bararam1 is compile time safe. And another advantage that Tour gives you over classical stuff is you sometimes want to have asynchronous factories, and there is not really a way to know whether or not a factory is async in classical service Locators. But with Tour, since it knows everything about the types of your factories and lazy singletons, you cannot not await them and use. Like if you create async factory with Tour, like register factory async, and this will be an asynchronous function that, I don't know, returns a number, you won't be able to use, or let's say it returns a class A. That would be nicer. Here, you can't really use that factory before awaiting, because this won't be A. This will be future of A. Yep. The value of type future A cannot be sent to a variable of type A. And if we make our main function async and we await this, then we have A and we can do whatever we want with it. What's wrong? Oh. Here we go. That's kind of it. If someone is interested, I can get into the implementation because there is some interesting stuff. If no questions, please.